Alright, so here we're doing quadratic roots, and before we dive deep into the actual quadratic roots, let's just go over some basic principles that we need to know, some tricks that you need to know in order for you to better understand how these roots come about. So let's say you have been given two values. Whenever you're solving a quadratic expression, and remember quadratic expressions are always written in the form of x squared plus bx plus c. This is like the general format of all sorts of quadratic equations or quadratic expressions. So now, if you have been told to say, okay, once you solved whatever this is, the answers that you got were maybe 1 and 2. Alright, so we can simply say x was equal to 1 and x was equal to 2. Then they ask you to say, go back to the original equation that you had. What do you do in this case? So what you do here is pretty simple. You are going to say, alright, since I have my x is equal to 1 and I have my x is equal to 2, I'm just going to bring them back to this side. So I'm going to say x minus 1, right? And then I'm also going to say x minus 2. And then what do? I kind of like combine these two together. So it's going to be x minus 1, and then it's going to be x minus 2 like that. And then remember, this was equal to 0. This was also equal to 0. So combining these two mean this will also be equal to 0. So multiplying that is going to mean you're going to have x squared and then minus a2x and then minus an x. No, that's not how I write an x. Minus an x and then plus a3, which is going to be equal to 0. So this is going to give you x squared minus 3x plus 3 is equal to 0. So this was the original expression. So if you start solving this equation, your answers should be x is equal to 1 and x is equal to 2. So this is a very important concept that you need to know, even as we start looking at these roots of quadratic expressions. So now let's look at something else. Now let's also try to look at it from this concept. So you have your x squared plus bx plus c like that, and this should of course be equal to 0. So let's say we're going to say this over a and then over a, so this is going to be x squared plus bx over a and then plus c over a is equal to this. Alright, so we have this. Now let us pretend, okay, it's not even pretending. We don't know the values of x, yeah? So in my previous example, I told you to say x was 1 and the other x was equal to 2. But in this case, we haven't been given the value of x. So we're going to say, alright, let x be equal to alpha. How do you write alpha? Something like that. And then let x be equal to beta. Alright, so you have alpha and beta as the values of x. So what is going to happen now? Remember what we did the previous time. Well, we said what we do, we come back this side. So it's going to be x minus your alpha, and then put it in brackets like that, and then another bracket, x minus your beta. Put it in brackets, this should be equal to 0. And then what do? You're going to say x squared and then minus beta x and then minus alpha x. Alright, I need to work on my alpha x and then plus alpha beta like that. Alright, and then from there you're going to say, alright, so I'm going to have my x squared, and then I'm going to say minus is common in between these two. Have you seen these two here? These two here, you can see that minus is common in between them, and then what else? X is also common in between them. So I'm going to get my minus, put it outside here, and I'm going to say minus, and then I'm going to put, okay, my alpha beta, my alpha sat, then just put my alpha like that. Alright, so I'm going to have my alpha, and then if I remove the minus, what am I going to mean with here? Plus, and then beta like that. And then remember, x was also common, so let me put x at the end there, and then plus alpha beta. So there is really no problem in putting the x in front, but it just doesn't look nice. So you rather put the x at the back there. But remember, negative and x were common between these two expressions here, and that's why I've written it like this. So boom, we have it like this. You've seen how we've written it, huh? Very nice, Jane. So we've written it like this. So now the question is, how do you move from joining this guy here to joining this guy on top here? You can actually connect these two, but how exactly is the connection between them? So now we can draw a conclusion just from here, just from this guy here. We can draw a conclusion, and what's the conclusion that we can see there? no, let me not get rid of that. Let me get it back. Alright, better. Let me rather get rid of that in the middle. Okay, so here we can draw a conclusion. And what's our conclusion? We have seen that our original expression was this guy here, and then this is our kind of like our actual expression after trying to find out what the original equation was. So you can actually relate between this guy here, the one that has an x, and the one that has an x, the one that doesn't have an x, and the one that doesn't have an x, and also the one that has x squared and the one that has x squared. So here it should be 1 here, and here there should be 1, which balances up. So you can also predict to say, okay, this must be equal to that down there, and then this must be equal to that down there. So from this general concept, you can say, alright, so if I have related them in that sense, then I can say, okay, my x squared from here should be equal to my x squared from here. Are they equal? Indeed, they are. They're x squared, x squared. So I don't even have to write that one there. So I move to my next one, which is going to be this one here. Is it equal to this one here? So I'm going to say b over ax should be equal to negative alpha plus beta. Remember, alpha plus beta are our roots, our values of x. So here we're going to say what? The x and the x can go on both sides, and then what we're going to mean with b over a is equal to negative this plus b. So changing that, this negative side, we're going to say over negative 1 over negative 1. So meaning alpha plus beta will be negative b over a. I'm sure we can see that, negative b over a. So we can conclude to say the sum of your two roots is equal to negative b over a. So if you add your two roots, your answer should give you negative b over a in order for this expression here to be the same as that expression there. So where did this expression come from? Remember, we were given an unknown quadratic equation, and then we're trying to find out what the values of a, b, and c are. Now, the values of a, b, and c are best known if you have your values of x. Remember, in the previous example, I said x is equal to 1, then x is equal to 2. But with this one, they didn't give us the values of x, so we assumed our values of x are alpha and beta, and then we tried to derive our equation, which came out to be something like this. And then after coming up with this equation, we are now trying to more like find a similarity between this equation that we found and the original equation that was given to us here. So we said x squared is equal to x squared, so that one has already passed. Now we equated this second one that just has an x with this other one here that just has an x, and then after evaluating that, we found that the sum of the two roots alpha and beta should give you negative b over a. Now let's move on to our last example. Hope it's clear up to that point. So not really our last example, but our last term here, which is c over a and alpha beta. So notice that we are targeting these guys in terms of their x's. So the first one that we started had x squared. The first one that we started with had x squared. The second one just had an x to the power 1, meaning the last one should have an x to the power 0, and anything to the power 0 is 1, so that's why this one doesn't have the x there. So we're going to target to say c over a, which is from here, should be equal to this guy here, which is alpha beta. And here there's really nothing to evaluate because we've seen to say, alright, so the product of these two guys here should give you c over a. The product of the two roots should give you c over a. Yeah, so there's that. So that's one conclusion that can be drawn. So we've drawn two conclusions already, and that is one, the sum of the two roots, whatever the roots are going to be, whatever the values of x should be, the sum of them, which is alpha plus beta, should give you negative b over a, and then the product of them should give you c over a. Product, this is alpha beta, like that, should give you c over a. So these are the two conclusions that we've drawn thus far. We can draw another conclusion in the general format of these expressions. So this is the conclusion that we can draw. So the conclusion is this: whenever you have a quadratic expression, which is ax squared plus bx plus c, which is going to give you 0, and then remember that expression that we had down here, it said what? It said x squared minus alpha plus beta x and then plus alpha beta. So we've seen that the what whenever you have this any quadratic expression like this, if you were to make the first guy here, the x, if you were to divide it by a like that, the general format of every quadratic expression should be x squared minus alpha plus beta x plus alpha beta. So if you know your roots, then you know the original equation, how it should be. Then you don't even have to start doing up the calculation that we said. So no, x is equal to alpha and then x is equal to beta. We've already done that up and we've concluded to say this should be like, you should end up to here if you start through all this process. You know the process for no, this comes this side, so it's going to be x minus alpha and x minus beta and the like and the like. So yeah, I hope you get the point that I'm trying to draw out here. Okay, so for every quadratic expression that you have, it will always be in this format where it's going to be x squared minus, here we can see alpha plus beta, so we can say the sum of the roots, x, plus, here this is the product of the roots, so that is the general thing that we're going to have. And what have we said the sum of the roots is equal to? Sum of the roots, which is alpha plus beta, is equal to negative b over a. Product of the roots, which is alpha beta, should be equal to c over a. However, there is another method in which you can come up with this alpha plus beta minus b over a, and then alpha beta c over a, and this one is very, very tiring. Very, very tiring. So let's look at it. So remember that the alternative way in which you can solve an expression is using the quadratic equation expression. So the quadratic expression says x should be equal to negative b plus or minus root of b squared minus 4ac over 2a, like that. So here we're going to have two values of x. So x will be equal to negative b, you just get the plus and then you say plus root of b squared minus 4ac. Then the other one is going to be x is equal to negative b, you get the minus now, minus b squared minus 4ac, like that, and then this is over 2a. Alright, and then once you have this, now let us try and find the sum of these two. So we can say this is x1 and then this is x2, or better yet, we can just say, like we did in our previous example, we can just say this is alpha and then this is beta. Okay, so now let's try and see if our sum of the root, which is alpha plus beta, and our product of the root, which is alpha plus beta, if it's going to give us negative b over a and also c over a, in that order. Alright, so starting with we said our alpha can be equal to, or let me just put x, not really even alpha, let me just put x. So our first x that we had was equal to negative b minus root of b squared minus 4ac, and then over 2a, and then the other one was x2. So this is x1, x2 should be equal to negative b plus what? Plus root of b squared minus 4ac over, sorry about that, over 2a. So that's going, that should be 4ac. I just can't, complete it all the way to the end, but yeah, that should be 4ac. So what's the next thing that we're going to do? The next thing that we're going to do is that we're going to try and find the sum of these big things and then also the product of these big things. So how do you find the sum of these big things? Alright, that's stuck there. Alright, some of these big things. The sum of these big things is what? So we're adding this plus this. So we're going to add negative b minus 4 root of b squared minus 4ac, and then over 2a, and then sum, so plus negative b plus root of b squared minus 4ac over 2a. So the common denominator there is already 2a, and then we're going to say this into that. It's just going to give you 1, so this same thing comes back here again, so it's going to be negative b minus negative b squared minus 4ac, and then again, same thing is going to come there, so it's going to be minus b plus root of b squared minus 4ac. So what things can you get rid of on top here? So let me just repeat that. Alright, so you can clearly see that this whole thing here, let me use a different color. This whole thing here is negative, this whole thing here is positive, so they're kind of going to cancel themselves out. So you're going to remain with what? You're going to remain with, I'm coming back here on top again, and then this is negative b, negative b. So negative b minus b, that's negative 2b, and then this is going to be over 2a. And remember, these two things disappear because this negative is positive. And then what do you see that's common there? 2, so it's going to be negative b over a. So this concludes us to say our sum of the roots, in this case we're saying x1 plus x2 is equal to negative b over a, or we can also say alpha plus beta is equal to negative b over a, which is the same as in our previous scenario case. And then what else can we do? We can also try and find the product of these roots, right? So let's try and find the products of the roots. So finding the products of the roots, you're going to say this. Finding the products of the roots, you're going to say, you had your negative b minus 4b squared minus 4ac over 2a, and then you had again a negative b plus this time b squared minus 4ac over 2a. So products meaning you're going to be multiplying, so you're going to have your big brackets there and your big brackets like that there. So what else are you going to say? You're going to say you're going to multiply these two together. So multiplying the things that are on top together, you're going to say negative b minus root of what? B squared minus 4ac pa, and then pa negative b plus this time root of b squared minus 4ac bar, and then down here is going to be 2a b multiplied with 2a in that order. So down here, let me just write the top evaluation because the bottom evaluation ain't that hard. So the top evaluation, this top evaluation is one that I'm going to write here only. So I'm going to say this times this is going to be positive b squared. What else? This times this whole thing again is going to be what? Negative b root of b squared minus 4ac. Okay, the root was too big. Negative b root of b squared minus 4ac. And then from there I can say what? This multiplied by this again, so it's going to be plus, because here there's a negative here, there's a negative there, so I'm going to say plus b root of b squared minus 4ac. Minus 4ac like that. Dang it. Alright. I've tried. Alright, and then the last one there is should be multiplying this with that there. So it's going to be negative, and once you multiply, this one has a root, this one has a root, so the root is going to disappear, but the negative will still be there. So we're going to say negative, and then we open our brackets, and then we just say b squared minus 4ac. Okay, my space is done, but you do know it's b squared minus 4ac. Why b squared minus 4ac? Because this one has a root, this one has a root. If you multiply them, the roots will just cancel out each other. You remain with what's inside, but here it's negative, and here it's positive, and the overall answer is negative. So you're going to have negative, and then in your brackets, b squared minus 4ac. Hope we're clear with that. So let me just rub on the top here. Lab on the top here. Let me just lab it a bit. Lab, yes, as I lab. Yeah. So labbing this after I have labbed it. So we see that what do we see? We see that this is negative, and then this is positive. They're typically the same thing, but negative, positive. So these two are going to go. So we're going to have our b squared, which is this first one here, and then here we had what? We had negative. Open your brackets. B squared minus 4ac. Alright, and then at the bottom here we had this one here that I left out, which was 2a multiplied by 2a, which should give you 4a squared. So opening your brackets on top there, it's going to give you what? B squared minus b squared plus 4ac. Then this should be over 4a squared. And then this, bring it here, you would say what? You would say So these two here will cancel out. Okay, not really cancel out, they'll subtract each other. So that's going to give you 0. So you're going to be with 4ac over 4a squared. So the 4 and the 4 goes. The a there goes, but here there are two a's, so one a is going to remain. So it's going to be c over a. So what are we trying to find here? Here we're trying to find the products of the roots. We're trying to find the products of the roots. Remember, x1 multiplied by x2, or alpha times beta, which is just alpha beta. So this is all giving you c over a, which has proved our initial analysis. So really this is very much important, because they can just tell you to derive how the sum of the two roots is equal to that, and how the product of the two roots is equal to that. So it's very important that you know how to do it.